is where you need to find the equilibrium concentrations without any of them. You only have initial concentrations. So, like I've mentioned before, because you have initial concentrations, that means ice table. So, go ahead and set up your ice table here with your reactants and product. Then you got ice, and I like drawing some sort of special line so that I know the difference between products and reactants. So your reactants are on the left, your products on the right. The mole ratios will also be important as always. The nitrogen is just 1, oxygen 1, and nitrogen monoxide is 2, so we want to keep that in mind. It tells us the initial concentrations are 0.200, 0.200, and it doesn't mention one for nitrogen monoxide, so we can go ahead and assume that's 0. Now, because everything is stoichiometrically related, when we've done it in the past, the change is where we can kind of look at the stoichiometric ratios. We know that because nitrogen and oxygen both have a coefficient of 1, that's going to be the small amount that we multiply by in the change depending on the mole ratio. So whatever value that is, that's x. Nitrogen will lose x, oxygen will lose x. They are both reactants, so they lose. Nitrogen monoxide is going to gain because it's a product, and since it has a coefficient of 2, it's going to gain 2x. So now you just continue it on through. At equilibrium, you're going to end up with, I'm going to forget the zeros for a second because I don't know if I can fit it, 0.2 minus x, 0.2 minus x, and then 0 plus 2x is just 2x. Now they gave us the K value, so your K expression would be nitrogen monoxide and then your nitrogen and oxygen on the bottom. Well, what we need to do is just plug in our values. So you get 0.1 for K, then looking down here you get 2x squared for nitrogen monoxide, and then you get 0.2 minus x times 0.2 minus x, and that is actually the same thing as, oops, I went too far, 0.2 minus x squared. Okay, so that makes it really easy. We just got to solve for x now. Eventually things are going to get harder and we'll have to do the quadratic equation. On this one we don't have to. We can take the square root of both sides. So you end up with the square root of 0.10 equals 2x over 0.2 minus x. Move the 0.2 minus x to the other side. So you get your square root of 0.10 times 0.2 minus x equals 2x. What you're going to do then is distribute the square root of 0.10 into the equation, and then at that point you'll have the square root of 0.10 times 0.2 minus the square root of 0.10 times x. Then you can move the 0.10 x to the other side to combine like terms. I don't have enough room here, so I'm just kind of talking you through it, and you'll end up with a square root of 0.10 is equal to about 0.3. So when you start solving for everything, you're going to end up with 0.063. That is the square root of 0.10 times 0.2 is equal to 2x plus 0.3x, which is the same thing as 0.063 is equal to 2.3x. Divide both sides by 2.3 and you get 0.027 equals x. Now, keep in mind that this right here is not your answer. We just solved for x. The question wants the equilibrium concentrations. So now you have to plug x back into the equations we had before. So 0.2 minus x is 0.2 minus 0.027, so you get 0.173 for both of these. And then 2x is your 0.054 molar. and those are all in molarity. The K value, of course, doesn't have units because it's a ratio, but molarities do. Now, that's the end of the problem. You might want to plug the numbers back in just to check yourself. If you do that, if you plug these values back in up here, you'll find that the K value is equal to 0.097. That's close enough to this. So we did it right, and your answers are down here. Sorry, they're kind of small. I'll do more of these as the problems get harder, but hopefully that'll get you off on a good start.